Welcome to the viewers. Now we discuss how to find out the derivative of some function, elementary function, using the elementary definitions of dy dx. At first, we consider the function exponential of x or e to the power x. How to find out? Let y equals to e to the power x. Therefore, fx equals to e to the power x. We calculate here f of x plus del x is equal to e to the power x plus del x, and we already know fx equals to x. Therefore, from the definition, dy dx equals to limit del x tends to 0 f of x plus del x minus fx by del x is equal to limit as del x tends to 0 e to the power x plus del x minus e to the power x by del x. We substitute the functional value. Therefore, limit del x tends to 0 e to the power x e to the power del x minus 1 taking common by del x. But here we find del x tends to 0 e to the power del x minus 1 by del x. This is one quantity and e to the power x. But e to the power x here we treat it as not variation of any kind of limit. So it is fixed term. Limit del x tends to 0 e to the power del x minus 1 by del x. But this is only 1 because we know limit as x tends to 0 e to the power x minus x 1 by x equals to 1 using this formula. So finally we find derivative of e to the power x, that is dy dx by definition is equal to e to the power x. Here we find the function fx equals to e to the power x. Here we find y equals to fx is equal to e to the power x. Therefore, so if y equals to e to the power x, from the definition we find dy dx equals to d dx of e to the power x, and that will give e to the power x. So in this way you can evaluate the value of e to the power x from the definition, elementary definition. And if we consider another function, just inverse of e to the power x, y equals to log x, if we consider here for the second function, then similarly we find fx is equal to log x. Therefore, f of x plus del x, that is log of x plus del x, and f of x equals to log x. Now from the definition, y equals to log x, therefore dy dx equals to limit del x tends to 0 f of x plus del x minus fx by del x. That will be limit as del x tends to 0 log of x plus del x minus log x by del x. Therefore, limit as del x tends to 0 log a by log b formula, log a minus b, that is x plus del x by x by del x is equal to limit del x tends to 0 log of 1 plus del x by x, but here we adjust del x by x into x, just to adjust this term. Now since del x tends to 0, just to rewrite the term, limit del x tends to 0 log of 1 plus del x by x divided by del x by x into x. This 1 by x constant treated to be, and limit del x by x tends to 0 log of 1 plus del x by x by del x by x, as del x tends to 0, therefore del x by x also tends to 0, and by definition 1 by x, limit z tends to 0 log of 1 plus z by z, let z equals to del x by x tends to 0, as del x by x tends to 0, therefore z tends to 0. It is a standard definition of logarithm and its value is 1, as limit x tends to 0 log of 1 plus x by x equals to 1. So finally we find 1 by x. Therefore we conclude ddx of log x is 1 by x, and obviously by definition x not equals to 0. Now we end our discussion today by evaluation of elementary function, that is exponential of x or e to the power x, and its inverse function logarithm of x. We end our discussion today, and if you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.